Here is something that will completely change how you look at the ring on your finger. Every single atom of gold on planet Earth was forged in one of the most violent events in the entire universe. Not in our sun, not in a supernova, but in the catastrophic collision of two neutron stars. And we actually watched it happen in real time. Let me break this down for you. When our sun eventually dies, it will leave behind a dense core called a white dwarf. But stars that are much more massive than our sun, roughly 8 to 20 times more massive, they die differently. They collapse so violently that their cores get crushed into something called a neutron star. A neutron star packs roughly 1.5 times the mass of our entire sun into a sphere just 20 kilometers across. To put that in perspective, 1 teaspoon of neutron star material weighs approximately 10 billion tons. These objects are so dense that their gravity warps spacetime around them in ways that are almost incomprehensible. Now here is where it gets extraordinary. Sometimes two neutron stars end up orbiting each other in a binary system. Over millions and millions of years, they spiral inward, losing energy through gravitational waves, getting closer and closer until finally they merge. When they collide, the temperature at the collision point reaches roughly 10 billion degrees Celsius. The explosion releases more energy in a fraction of a second than our sun will emit over its entire 10 billion-year lifetime. This event is called a kilonova, and it is the primary cosmic factory for heavy elements like gold, platinum, silver, and uranium. For decades, scientists suspected neutron star mergers were responsible for gold production, but they had never actually caught one in the act. That changed on August 17, 2017. At 12:17 UTC, the LIGO and Virgo gravitational wave detectors simultaneously picked up a signal designated GW170817. Within 2 seconds of that detection, NASA's Fermi Space Telescope registered a gamma-ray burst coming from the same direction. The signal came from a galaxy called NGC 4993, about 130 million light-years away. Within 11 hours, telescopes around the world had locked onto the location and they began watching a kilonova unfold in real time. Over the following days, spectral analysis confirmed what scientists had theorized. The explosion was producing enormous quantities of heavy metals. Estimates published in the journal Science suggest that a single kilonova can produce masses of gold equivalent to several times the mass of Earth itself. Some calculations put the gold yield from GW170817 alone at roughly 10 Earth masses of pure gold. The research team, which included scientists from the LIGO scientific collaboration involving over 1,000 researchers across dozens of universities, published findings simultaneously in over 50 scientific papers. This single detection event fundamentally confirmed the R process, short for Rapid Neutron Capture Process, which is the nuclear mechanism by which heavy elements are assembled during these collisions. Neutrons slam into atomic nuclei so rapidly that unstable isotopes form before they can decay, and as the debris cloud expands and cools, those unstable atoms decay into stable heavy elements including gold. Prior to this discovery, the origin of gold was genuinely one of the great unsolved mysteries in astrophysics. Some models pointed to rare types of supernovae, but the numbers never quite added up. The kilonova confirmation resolved decades of debate. What makes this even more personal is the timeline. Our solar system formed about 4.6 billion years ago from a cloud of gas and dust that itself was enriched by previous stellar explosions and neutron star mergers that happened billions of years before our sun even existed. The gold in your jewelry, the platinum in catalytic converters, the uranium in nuclear reactors, all of it was scattered across space by collisions that predated Earth itself. And here is the final twist that almost nobody talks about. Scientists at the Massachusetts Institute of Technology and Caltech have estimated that only about 1 in 10 million stars will ever produce a neutron star merger. These events are extraordinarily rare on human timescales. The next observable one in our cosmic neighborhood could be thousands of years away. So next time someone hands you a gold coin or you see a wedding ring, You are literally holding the compressed legacy of two dead stars that spiraled toward each other across millions of years just to produce a handful of the rarest atoms in the cosmos. That gold traveled 130 million light-years before ending up in your hand. Space is not up there. Space is on you.